Welcome back to question B-1 in 2014. It's an intersecting planes question. So the image across shows the Halle Berry reveal perfume bottle. The cap at the bottom includes intersecting planar faces. Okay, so our cap there, we've got some faces on it. Now the preview. For your B1 shows the plan and elevation of two of the intersecting planes A, B, C, D and A, B, E, F, G. The horizontal and vertical coordinates of the two planes are also given. So we've got our coordinates going out, up and down. Okay. Draw the given elevation and plan of the two intersecting planes. And just looking down along here, they've given us all the coordinates for A through to G, so that's no problem at all. So on my page, I am going to come in all of these measurements, 100 being the shortest one. So I just want to make sure I've got enough space on the right to do different elements of the drawings, facing the left and right, and situate this in the middle of the page. So I'm actually going to come in a little bit first of all and say approximately there. So this will be where I'm going to take my measurements from. Okay, so we're going to go 130 to A, B is 140, C 100, D 110, so just label all these, C, D, E is 210, so is F and 190 for G. So E and F are in that position. Okay, and now my vertical measurements. So we got up 55 from A, and down 90. And I've got B 85 and 80, so 85 and 50. C, we've got 85 and 50 also. D is 55 and 90. E is 45 and 10, so E 45 and 10. F is 25 and 30, so 25 and 30. That's my F, that's there, and E, just to make sure I don't mix them up. And then G is 25 and 60, so 25 and 60. Okay, so A, B, C, D, B. I've got G, let me double check that. G is 60 down. There's 60 down to G. I've got my E and my F. Okay, so let's draw these up. I've got my planes A, B, C, D. And I know the heights of some of those are the same, so it's a nice quick one to draw those using horizontal lines. we've got A, B, C, or A, B, G, E, F. Lines. Same height there. Probably using a T-square just to make sure we got a nice horizontal line. Might be useful later, we'll see. Okay, so it's a setup of my question. Elevation plan completed. Determine the dihedral angle between the planes. So first of all, I need to establish, is there a line of intersection between them? And my planes there, we've got AB and AB, so the line of intersection is AB, and we can even see it there. So I want to first of all find the true length of that line, okay, and then look along that. So down here, this is my line, so I want to look perpendicular to it. Then we get my line and set squares. XY line. I actually want to project up the full planes. I'll just create something to go along that. So, yeah, first off, let's deal with AB. Okay, I'm creating an auxiliary elevation, so my heights are coming from the elevation. So height of A, go around to A, here's my height for A, and my height for B, down to B. Okay, so that is the true length of line AB. AB, that's my X1, Y1. Okay, that's my XY line. Okay, so I could project up the entire planes, but just to simplify this a small bit, I'm actually going to create a plane. Here. So I'm going to create a new plane, or a smaller plane, a lambda ABCD, and ABG. Okay, so this is a plane. I'll show those planes up here as well. Okay, if I find the dihedral between those smaller planes, it will also be the same dihedral angle for the rest of those larger planes. Okay, so let's find D and G out here also. D, let's project that out, and G, project it out. Heights taken from the elevation. The height of G and the height of D is actually going to be the same as the height we had for A. Same height. So here are our planes that we're going to be dealing with. That's D and G. Okay, so I've added a little bit of colour there to that, just to show those couple of planes a little bit clearer. So Now we're going to project along that true length line. This line AB, as I said, is a true length line. So we're going to look out along it, and that will show us the dihedral angles. Projecting out along there, AB, D, and G. X2, Y2. Okay, so we're going to take our distances then back, two views back from the X1, Y1 back to our plan view. So AB, just to prove it, should be appearing as a point view, and I've got the distance from my AB will be the same distance for both of them. So AB projected out. There we have it. G, the longest distance there. Follow G out. And D, so there's G, A, comma B, and D. Okay, so my dihedral angle then, if you want to measure it, as best we can, line up the bullseye. I have that at 140, I suppose 142. Okay, so that's my dihedral angle between those planes. Tick that off. Determine the true shape of surface ABCD. Okay, so ABCD is here and here. Now AB and AD in both views, they're actually true length lines. Okay, because they're horizontal here, so looking down on the plan, they're true length lines. So I could actually take the distance between AB and these, which is the same as the distance between CD, and actually draw it out separately here in the diagram. But just to kind of show the examiner what I'm doing, I'm actually going to I'm going to rotate this. Okay, so what I'll do to rotate is I'm going to I'm going to rotate about AD. So if you imagine that surface, I'm going to rotate it until I see it down here in this position. Okay, they've allowed us that position for a reason. So rotating the full surface down and around. You see that? So we're going to rotate that down and around so it's down there. Okay, or rotating it down like that so that we're looking directly in it. So B and C are going to stay along that track as it rotates. A and D are going to stay in the same place because that's my point of rotation. Okay, but I need to see this as an edge view first of all so that I can rotate it. So I'm actually going to create an edge view out here to the right hand side, or to the left hand side. So let's just create an edge view. Do an edge view anywhere else? No. Okay, so I'm going to draw. Check that here. So I'm going to situate CD, they've been projected there. I'm essentially creating an end view, kind of looking in from this side of those. So this is point CD, and AB will be out here along there. So they're actually going to create a little datum. So I'm looking in from here, almost like an end view. So that distance there, so that's the point view of A, D. Here we have an edge view of it. Okay, and like I said, I'm going to rotate that down into this position and project it back and show it in here. So project that down. That's a new position for that. Let's project it back. Okay, AD stay in the same position, or sorry, AD stay in the same position, CB have been rotated down, so they're down into this position. So that's my C, that's my B. Okay, so that's it having been rotated down there. If you wanted that colour, you could. So we have determined the true shape of surface S completed. Right, on another surface S, on the bottle cap is a regular hexagon. Okay, a regular hexagon. We can see here that's the shape there, S. EF is one of those sides, so EF there is one of those sides. Okay, and it's a regular hexagon, so EF will be the same length as all the rest of those sides. On a separate diagram, draw a full size and true shape of hexagon S. Okay, so let's look first of all at E and F. So E and F there, it's sloping away from us in this view, kind of like that, and in this view sloping up towards us. So it's not a true shape or true length, excuse me, in either of those. So I could either project out here and draw an auxiliary elevation of it, or I can rotate it, and I'm going to rotate it around to find the true length. So I'm going to rotate F into that position. So F is going from here into this position, so when we look at it in elevation, we see it's the true length. So rotate EF around to there. That's the new position. Okay, F, the height of it isn't going to change as it rotates, so it's going to be there. So here is the true length. So true length of EF. Okay, now draw a hexagon. Okay, hexagon has 6 sides. Okay, and it's a regular hexagon, so 6 sides, it's 360 divided by 6 gives me the external angle there and there, which is 60 degrees. Okay, so that's 60 and that's 60. So let's start off by drawing the length of one side. So we get a compass, set it to the true length of EF. So that's the length of one side. We'll draw that in heavy. We're going 60 degrees. 60 degrees. Let's get that compass again. Swing it out. And swing it out. Okay, and back at 60 degrees again. same distance, find it up here and here. Okay, and let's draw that in heavy to finish it off. True length, the true shape of that hexagon found. Okay, so that's the 2014 Intersecting Planes question concluded there. A nice question, good balance of dihedral angles, true shapes, true lengths. So a nice question there, 2014.